first of all, let me just say I'm a pavement management guy for Oregon DOT, so this stuff is my world. You know, most of the time I get the questions, John, what are we going to do with road XYZ, or you know, we got $10 million to spend for the next 2 years. What should we do? And so this is my subject matter, and I've spent a lot of time trying to dig into the information. As Rod probably mentioned, a lot of this stuff is now we have data in place. We've been collecting data for a long time over the years, and so we have a lot more information now available with which to make some decisions about what we're doing. This chart here is basically real world cost information and life information as best as I can put together for the types of preservation treatments that we have. And I basically, when we talk preservation for this group, I mostly consider those top three treatments as the preservation treatments. In our world, we have a preservation program, but we do a heck of a lot of this stuff too in our preservation program. And even some of that we call preservation. It's just the way, it's a nomenclature thing. We're never going to get away from it probably in Oregon, but that's just the case. But generally speaking, you know, these are the costs that we pay to do this type of work. And we do a lot of stuff with dollar per lane mile instead of dollars per square yard. That's just the world I live in. But this one happens to be highly variable, and of course it depends on the road. But $3,000 a lane mile is probably a high number, but that's a good average. You know, and then we have, of course, the Cadillac treatment. We like to do some of those too in our mix of fixes. Those cost us a couple $1 million per lane mile. But notice there's a big difference in how much life they give us. And so I think the point here that I'm trying to make is preservation always comes out on top if you take the unit cost per lane mile and divide by the number of years you get. Preservation treatments are always going to come out on top. And actually, it's really an order of magnitude thing. Most of the preservation treatments that I'm talking about generally give us somewhere around, you know, less than $10,000 per lane mile year, whereas, you know, our more heavy rehabilitation type activities are generally over $10,000 and upwards of, you know, $40,000 or $50,000 a lane mile a year. And so really the point of this slide is, I'll get to it in a minute, but the point of this slide is, if you can do something with preservation to extend the life of your pavement, you know, even if it's 2 years, 5 years, before you need to do the resurfacing, then by all means you should do it. Now, if you have an IRI problem or a rutting problem, that paving is the only thing that will solve it, don't put a preservation treatment like a crack seal or a chip seal down. That's the wrong treatment for the road. But when you have a situation where you have a smooth ride, minimal rutting, you got a cracking problem, then do the cracking type fix. Try to extend the life of your surfacing if you can. Now, obviously, if you got a lot of moderate and high severity alligator cracking and pumping, you know, you're not going to get anywhere with this type of treatment. And these are averages, but the point is, extend the life, your cycle time between your surfacings. So here's a scenario that I just wanted to paint. I get this all the time. This is a pretty good road by and large. This one's an 8-year-old road. It was a hot mix pave. I think this one we actually did during ARA. You know, we got all that influx of money and went out and paved a bunch of roads. Well, guess what? It's been about 6 to 8 years since ARA. Now what do? We got a lot of roads with hot mix on them. This one is a condition rating of 72. We have quite a bit of wheel track cracking. You're not really going to see it very well in this picture, so we have this downward picture, and anywhere inside that green there's actually a longitudinal wheel track crack in there, probably a top-down crack. Maybe the bond wasn't the best it could be to the layers below. Maybe there's a little bit of a fatigue issue, or it could be just a little bit too stiff in the top lift. But the thing is, our IRI is a 60. It's really a nice road. There's not much writing on it. Well, I got two choices. I can just leave it. It's good. Or I can actually do something about it now to see if I can extend life to it. And so let's take a look at some of those, how those two options might play out. This is scenario one would be the traditional approach for this road. Just, hey, this is good. I'm not even going to think about a road like this. It's not even on my radar. And that's usually what most maintenance guys would say. That's not my problem road. My problem road is over here where I got to do all the patching or fix the potholes. Why we need to do those roads. And then option two would be the preservation option. That would be where we do something now to try to extend the life of this road so we can defer the resurfacing. And so I did basically a quick tally of a couple different scenarios with treatments on them, and then looked at the equivalent uniform annual cost. And this is fairly simple to do, pretty standard stuff. And basically, this is really using reality in our system. Is if we don't do anything today, and it's 8 years old, about 6 years from now, we'll start to get moderate severity fatigue cracking show up. Those longitudinal crackings will start to branch out. Pretty soon we'll be patching those, and generally speaking, it costs us about $5,000 a lane mile to patch it. And about the time we patch it is when we program it into our STIP, which is another 5 years away. And by that time, it'll be 18 years old, and a lot of 18-year-old roads for us, we end up doing multi-lift treatments on them if we don't catch it in time. So we would pay for a typical multi-lift $270,000 a lane mile. And that's a pretty big number when you look at the EUAC numbers. If we just did the same thing and turned around and patched it again at age 14 and did another multi-lift at 18, we'd be looking at overall, at the end of it all, a 40-year analysis period of $13,000 a lane mile year. If we did a preservation type scenario where we got on it, we crack sealed it, did the chip seal, we're going to spend money today that we wouldn't have had to spend. So it's a little bit painful. You have to actually empty your pocket a little bit. But in the long run, we're going to save some money. Because what's going to happen is if we do that chip seal today, at year 18, we would have had to do a multi-lift. Well, when we do a chip seal, by the time it gets to 18 years since the last overlay, it doesn't need a multi-lift treatment. In fact, sometimes you can do another chip seal. It kind of depends on the road. But for my case, I'm kind of making this up using anecdotal data. But in my case, I see a lot of times where if we had put a chip seal down, we're able to come in and do a mill fill or a standard overlay on top of it, because the alligator cracking that started didn't branch out and start to break down the wearing course. And so just follow that out. If you did a chip seal, then the single lift, and did the same thing again, a chip seal about midway through the life, did another single lift. At the bottom of it all, you're spending $10,000 and you're saving yourself about 20% in the long run. That doesn't seem like a big number to me. In fact, I thought it would be more, but this scenario really is a high traffic, high volume, state road type scenario. This is not a typical county or say an area with residential streets. I think that the value of chip seal is a lot more, to be honest, on a lot of those roads. In fact, a lot of times that's all they get, and they do quite well with just a little bit of patching and chip sealing, because the life extension that you get out of the chip seal is far longer than the 5 years that I'm seeing on the high volume state highways. So what does this 22% savings really mean? For us, we invest about $15 million a year in chip seals. And so if you take that 15 million and figure that that's saving you 20%, that's really saving us about $3 million a year, in the sense of we spend $15 million, we actually get $18 million of value out of it. And over a course of 10 years, that's $30 million. Now you're starting to talk about real money. And this is just a scenario for high volume roads. I don't even have a scenario here for low volume roads, but honestly, we have roads in our low volume system where we've done multiple chip seals, 2, 3, sometimes in cases 4 chip seals. It's been 30 years since we've done any type of major activity on them. They still have good IRIs, they still have good rutting. They really don't have the traffic volume, but because we've kept up on those preservation treatments, they're still in good shape. And so we've extended that time way, way, way beyond a typical 20-year type repave interval. And so I brought this slide, and there's a lot of stuff on this slide, but what I wanted to show is we basically have 3 systems that we're managing, and the interstate system by far carries the most traffic. And the interstate carries, in 1 year, more traffic than most of the rest of our system sees in 20 years. And that's just a fact. There's so much truck, I don't want to say traffic so much as truck volume, easels. The easels that the interstate system has to carry is tremendous. It's the major proving ground of anything related to pavements. You have to have your best pavements out on the interstate, otherwise they will not survive. So what it turns out is we end up funding them at a level somewhere around $50 million a year in our federal aid STIP program, doing mostly multi-lift and single-lift type treatments and occasional rebuild. But generally speaking, our funding is right around $16,000 per lane mile a year, which is, I'd like to have more, but we can do pretty well with that. And on average, we're looking at cycle times of about 15 years on the interstate. We have studded tires in Oregon where the studded tires do chew up the roads a little bit. Some of our routes in Oregon, we have to do cycle times down around 8 to 10 years. Other parts of our system, of course, the concrete ones last much longer and kind of average that out. But 15 years is pretty typical of the lifespan of an interstate pavement before it's time to do another hot mix overlay. When you get to the non-interstate, the NHS system and some of our higher volume routes, the funding level that we have going in is only $7,000 a lane mile a year. Well, that's less than the numbers I just showed you before. I had $10,000 for the preservation scenario, $13,000 for the traditional approach. So that already we're underfunded, but at least with the preservation scenario, we've shaved $3,000 off the lane mile a year, and all we need to do is shave another $3,000 off the lane mile a year to keep our system at least afloat better than it is today. We're still looking at cycle times of 34 years average paving. So really the reality is we're doing 20-year cycle times on the roads that are the most important, and we're putting the rest, we're kicking the can down the road on the rest, to be unfortunate, but that's just the reality of our funding situation. And then we got the low volume system, and the low volume system, the funding level of the low volume system is really only, it's dire. It's less than $2,000 per lane mile a year. I've seen it for the last 15 years. We've funded that system at about $2,000 to $3,000 per lane mile a year, and the conditions on it have held constant, thanks largely to pavement preservation type treatments. We're just starting to see where it's catching up to us, and that funding level has been coming down recently. And it's not so much the funding levels come down, it's we kicked more miles into that system and basically handed it off to that program, to the point where now our cycle times for even chip seals are 10 years, and most of the time we're only getting maybe 8 to 9 years out of those treatments. So we're slowly getting to the point where, to be honest, we're not chip sealing all the roads that we should be. We have to make choices about which ones we do. Some of them we're patching, some of them we're just crack sealing and saying that's all it's going to get. But I'm kind of digressing from the topic of cost effectiveness. But what's the point here? When you do this for your funding, when you calculate this out and then compare it with what you should have for, for proper managing your pavements. This kind of tells you a lot. If you're in the ballpark, that's good. If your funding level's like this and your demand is $10,000 lane mile a year, you got a funding problem, and you got to do something to take care of that. I have one last slide. I think we were asked to talk about good practices, so I just threw some bullets together. But on the pavement management side, I think good practices for this cost effectiveness is we've been able to defend a dedicated and predictable funding amount and keep it away from being taken. And that's not an easy thing to do. It's always been something that's been asked and questioned and challenged, is whether we can take some of that money. Usually we have an urban-rural issue. If you had Oregon, here's Oregon, right? You got Portland and you have everywhere else. And everywhere else gets all that chip seal money, and Portland's wondering why we're spending all this money on chip seals when they have all these issues that aren't being addressed, right? Well, thankfully, we have some good leaders in our agency, and I'm just a message carrier. I bring the message about what can we do, what are we doing with the money we have. It resonates, thankfully, and so far we have been able to keep this dedicated, predictable funding. And so that's my job, to keep hammering that in. Second thing I've learned on the job is don't wait too long to apply the preservation. Especially when we talk to our maintenance folks. Most of our maintenance folks, they want to solve the problem they have today. They want to put the chip seal on the road that's too far gone. They want to come and patch out the bad spots and chip seal it, and then it makes it look pretty. Well, it's kind of a fundamental shift for them to think about chip seal on the road that I showed you earlier in that slide, which is a good looking road. There's not a patch on it, just got a couple of cracks. The maintenance guy would say, hey, what the hell? And what I'm trying to say is, what you want to do is get that earlier, and it's not an easy thing to do. I think I'm making headway, and I got a guy out there in the Dalles. He's one of my biggest supporters, but he's coming around, but he's slow, and most of these maintenance guys are slow on that concept. Our design folks get involved. They actually give us a second opinion on this, because they're the ones that we actually stamp preservation treatments, believe it or not. They check structural health, they evaluate alternatives, they look for problems we have with materials, make sure we're not doing something dumb like putting down a chip seal over a material that is strip susceptible. We got materials folks that are working on the preservation stuff. Recently we've started a chip seal research project looking at application rates, and possibly to the point where we'll use some of that information to let the contractor actually set some of that stuff, and like a warranty type of a situation. We're looking at, we have done some annual chip seal workshops. We've actually done 4 thin 1-inch pave projects in the last couple of years. And then we did a microsurfacing last year to correct up ruts which was an extension of a chip seal job. And the last thing I think on pavement preservation is, this is more of a durability thing, but over the course of the last 15 years, we've changed the way we do mix designs, we changed the way we spec asphalts, we change how much wrap we put in mixes, today we're putting more shingles in our mixes, we put in additives to get warm mix out of it. Asphalt is not a stagnant thing, and every time we mess around with our hot mix, it does impact performance to a certain degree. So what our materials guys, their job is to make sure that even though we can't continue to mess with hot mix, their job is to make sure that it still lasts like we think it's going to last. So this is what we've done in the last 5 years. I hope I didn't take too much of your time. Thanks. Questions? I'm here for a couple days.